Hello everyone. So in this video we are going to discuss the May-June 2020 9709 Pure Mathematics 3 solutions, and this is 3-2. Paper code is 3-2. So let's start with the first question. Here's the first question. Find the quotient and remainder. So we need to divide when this is divided by this polynomial. So let's divide it. 6x to the power 4 plus x cube minus x square plus 5x divide by 2x square minus x plus 1. So we'll take the leading terms. We'll take the leading terms of dividend and divisor, and we'll divide. We'll get 3 times x square. 6x power 4 over 2x square is 3x square, and we'll multiply it in completely. Then we'll get 6x to the power 4 minus 3x to the power 3 plus 3x square. And now we'll change the sign because we are going to subtract it, and then these two got cancelled. 3 plus 1 4x to the power 3, and it is minus 4x square plus 5x. Oh sorry, I forgot the 6, so minus 6 will come here. Now we'll take the leading term again to divide. 4x cube minus divide by 2x square, that is 2x, and hence it is going to be 4x cube minus 2x square plus 2x. Now we'll subtract it, and then this sign got changed. This is cancelled. It is minus 2x square minus plus 3x minus 6. And now if you'll divide minus 2x square by 2x square, then you'll get minus 1. So it is minus 1 times, and hence we'll multiply. It is going to be minus 2x square minus plus x minus 1. And now we'll change the sign, minus, and here plus cancelled. It is 3 minus 1, that is 2x, 6 minus 6 plus 1 minus 5. And here we got the quotient. Quotient is 3x square plus 2x minus 1, and the remainder is 2x minus 5. I guess it is okay. Let's do the next question. Here is question number 2. The variables x and y satisfy the equation y square is equal to a times e raised to the power kx, where a and k are constants. The graphs of L and y against x is a straight line passing through the point this and this as shown in the diagram. Find the value of a and k correct to 2 decimal places. So first of all, we see that there is a x in the power, so we'll take the log both the side, and we will get 2 times ln y. I am taking log base e, that is ln y is equal to ln a plus, we know it is ln a raised to the power n can be written as n times ln a, so it would be kx times ln e, and ln e is 1, so it become ln a plus kx. And now at minus 1.5 comma 1.2, so we know it is going to be x, and it is going to be ln y because it is a graph on ln y against x. Hence it is going to be 2 times ln y, that is 1.2, is equal to ln a plus k times x. K times x means 1.5 times k. This is equation number 1, or we can simplify it is as 2.4, and at 5.24 comma 2.7 we will get it as 2 times 2.7, that is 5.4, is equal to ln a plus 5.24 times k. This is equation number 2. Now we need to find the k and a value, so we'll subtract the equation 1 from 2, and we will get 5.4 minus 2.4 is 3, is equal to ln a minus ln a is 0, and 5.24 minus 1.5, 5.24 minus 1.5 is 3.74 and hence from here we got k value as 3 over 3.74, which is going to be 0.80213 and so on, and hence it can be written as only 0.80, so it is 0.8 only. And now correct to 2 decimal places, so it would be 0.80, sorry, because it says that it is to be written till 2 decimal places. So from 1 we can write it as 2.4 is equal to ln a, because we need to find the a value, plus 1.5 into k will not take this value as k because it is corrected to dp, so we will take till 3 significant, that is 0.802, and which can be written as ln a plus 1.203. so it means ln a is equal to 2.4 minus 1.203, which is going to be, let me calculate it, it is going to be 1.197, and hence a will be e raised to the power 1.197, and it is going to be, let me calculate through the calculator, it is coming 3.3101 and so on, so it can be written as 3.31 because we require the answer till 2 decimal places. And let me tell you how I can write this, though I know that you know it, but we have used the definition of log. If like log a base b is equal to c, it means a is equal to b raised to the power c. That's what I have used, and we know that ln means base e. It is a natural log, so it is base e. I hope it is clear. So let's do the next question. Here's question number 3. Find the exact value of this. Exact value of this we need to find, and we have x to the power 3 by 2 and ln x. We know that whenever you have ln x and any other algebraic or exponential form, so we need to take ln x as the first function. So we will write again it as ln x into x to the power 3 by 2 and dx, and then we'll use the integration by part. So integration by part means first function as it is, that is ln x as it is, into the integration of second one, x to the power 3 by 2 plus 1, and divide by the same thing whatever answer comes, so that is going to be 5 by 2 plus, sorry, not plus, minus integration of differentiation of first function. Differentiation of first function is 1 over x, because ln x differentiation is 1 over x, into integration of the same thing, so we will get x to the power 5 by 2, because we know that it is going to be this, over 5 by 2 and dx, and hence, and plus c, of course there would be a constant of integration, and it can be written as 2 over 5 x to the power 5 over 2 ln x, minus, if we'll solve it, we'll get 2 over 5 times, and this is going to be again x to the power 3 by 2, and x to the power 3 by 2 is integration of that is going to be x to the power 5 by 2 upon 5 by 2. We know that 5 by 2 minus 1, 5 by 2 minus 1 will be 3 by 2, and the integration of this is again 5 by 2 plus 5 by 2 over 5 by 2 plus c, and which can be simplified and can be written as 2 over 5 x to the power 5 over 2 ln x minus 4 over 25, I multiplied it here, into x to the power 5 by 2. And so sorry, actually this is the definite integral, so no need of this c. I'll apply the limits over here, limits. So the limits are going to come here, that is 1 to 4, and hence it is going to be even if we are applying the plus c, but at that time because we need to put the limits, so it will automatically go on. So I'm going to put it here. I'll take 2 by 5 common, and then putting the upper limit, that is x is 4 to the power 5 by 2 into ln 4 minus 4 4 over 25 become 2 over 5 because 2 over 5 I have taken common, and x to the power 5 by 2, that is 4 to the power 5 by 2, and then subtract, put the lower limit, it is 2 over 5 x to the power 5, that is 1 to the power 5 by 2 is 1 into ln 1 is always 0, and minus 4 minus plus 4 over, sorry, not 4 over again because I have taken 2 by 5 common, it is going to be 2 by 5 times 1 to the power 5 by 2, that is 1. So this is the answer. Let's calculate it. It is going to be 2 over 5. You know that we cannot put the value of ln 4 because we need the answer as the exact value. So it is, and 4 is 2 square, so this will be gone, and we are left with 2 raised to the power 5, that is 32 ln 4, and here it is 2 raised to the power 5, 2 raised to the power 5 is 32 into 2 is 30, 32 into 2 is 64 over 5 minus 0 plus 2 by 5, and which can be simplified as 2 over 5. Let me scroll up. 2 over 5, and it is 32 ln 4 minus 62 over 5, and then I'll multiply by 2 by 5 here everywhere, so we'll get 64 by 5 ln 4 minus 62 into 2 is 124 over 25, and this is the final answer. I hope it is clear. Let's do the next question. Question number 4. A curve has equation y is equal to cos x into sin 2x. Find the x coordinate of the stationary point in the interval this 0 to pi by 2, giving your answer correct to 3 significant figure. So for a stationary point, we know that dy over dx is equal to 0. So we have y, so we can find ddx of y, and we'll use the product rule because there are two functions. So first function as it is, that is cos x as it is, and differentiation of sin x is cos x, and that is cos 2x, sorry, cos 2x here, and into multiply by, this is a chain rule we are going to use, and differentiation of 2x, that is 2, and plus sin 2x as it is, second function as it is, and differentiation of first function, that is minus sin x. This will be equal to 0 for the stationary point, and hence we can write it again, it as 2 times cos x cos 2x and minus sin x sin 2x is equal to 0. So for a stationary point, so x coordinate, this is 0. Now we need to find the value of x from here. So there are so many 2x, this double angle, so that we can get the things in the cos and sin separately. So it is 2 times cos x into cos 2x is cos square x minus sin square x minus sin x into sin 2x is 2 sin x cos x is equal to 0. Now we can divide the whole equation by 2 because 2 is here also, it is gone, and then next is we are going to write it as cos cube x minus sin square x cos x and minus sin square x cos x is equal to 0. So we got it as cos cube x minus, and the same thing like term, so it is minus 2 times sin square x and cos x is equal to 0. Now we'll take sin cos x common, we'll get cos x into cos square x minus 2 times sin square x is equal to 0. So now we got the product of two functions, so it would be like separately there should be 0, It means cos x will be 0, or the bracket, another bracket, that is cos square x minus 2 sine square x is equal to 0. And we know that cos x is 0 at 0 in this interval 0 to pi by 2. Cos x is 0 at pi by 2, and pi by 2 is not there in the interval, so we cannot take this, it is not possible. So we have the another function. So in this interval we need to find, and let's do it by I can write it as 2 sine square x is equal to cos square x, and hence I'll divide by cos square x both the side, because cos x cannot be 0, that's why we can divide it by cos square x, and hence we'll get 2 times tan square x is equal to 1, or tan x is equal to plus minus 1 over root 2. And we know that in this 0 to pi by 2, in this 0 to pi by 2, tan x is not going to be negative, hence we'll find the value of x where tan x is equal to 1 over root 2. Hence x will be tan inverse of 1 over root 2, and we are going to calculate this through the calculator from in the radian, because the interval is given in the radian form. So it is tangent inverse of 1 over root 2, and it is coming 0.61547 and so on. And let me see, they have written that specifically that you require to write the answer till 3 significant figure, and hence x will be 0.615. I hope it is clear. So that's it for in this video. We will be discussing the next few questions in the next video. Thank you so much.